In this video tutorial, we will look at logarithmic functions. If we were looking at something like how many times would you have to double $1 before you had $512, you could solve this problem if you could solve 2 to the x equals 512, because we double it until we get $512 by using an inverse operation. So we know those as plus and minus and times and divide and square root and square. Those are all inverse operations. And it undoes the raising a base to an exponent equation to model the situation. This operation is called finding the logarithm. A logarithm is the exponent. And that's the most important part you have to remember, is that the logarithm is the exponent. So anything having to do with an exponent, we can use for logarithms. So it is, a logarithm is the exponent to which a specified base is raised to obtain a given value. So when we look at converting from exponential to logarithmic form, we have this process. So if we have a base raised to a power equals a value, then the log of that base, given the value a, is x. So keep in mind that this is the exponent, and so is this whole thing. The log base b of a value a is the exponent. Keep that in mind. So if we look at a logarithmic function below, because the logarithm are the inverse of exponents, the inverse of an exponential function, such as y equals 2 to the x, is a logarithmic function, such as y equals log base 2 of x. And keep in mind, when we do inverses, we switch the x and the y. So while these both say y equals, we can think of it as we really have this. So we have log base 2 of the value y, and that equals x. But as we write inverse functions, we actually write y equals. So keep that in mind as well. You may notice that the domain and range of each function are switched. So where we had this exponential, we know that it flips over the y equals x line, and all the points flip the x and the y. So what you'll notice is you have that reflection, and that changes the asymptote to flip to the x, and the range to flip over to x value. So the range and the domain kind of switch each other. So the domain of y equals 2 to the x is all real numbers. So meaning we can pick any real number and we'll get a real answer. And the range is y greater than 0. So as we approach that asymptote, we have to have values above 0 because we can't have a fraction that does equal 0. So the domain of y equals log base 2 of x is x greater than 0, because now we've switched that asymptote right here. and the range now becomes all real numbers. Because on this graph, I can pick any y value, because this continues on and on and on, and any y value going negative. But my x values have to be greater than 0. And we have special properties. So, oops, a logarithm is an exponent. We said those are equal. So the rules for exponents also apply to logarithms. So as we go through, we'll be applying properties of exponents to logs. You may have noticed the following properties. In the last example. So if we have log base b of b equals 1, so that would mean that b to the first equals b. Okay, that makes sense. Log base 10 of 10, well 10 to the first, so we go this way. 10 to the first equals 10. So b, and then logarithm of 1, so if we have log base b of 1 equals 0, that's because b to the 0 equals 1. And log base 10 of 1 equals 0, that's 10 to the 0 equals 1. So a logarithm with a base 10 is called a common logarithm. And just like when we have 1x, we just write x, or we have x to the first, we just write x. So the same is true with logarithms. So if no base is written for a logarithm, the base is assumed to be 10. So you may expect it to say log base 10 of 100, but we as mathematicians, if it's the same thing over and over, we like to leave things out. So you would see this instead, where the 10 is just assumed, just like it was here with the x to the first and 1x. So if we have, whoops, log of 5, that really means log base 10 of 5. And you can use mental math to evaluate some of the logarithms. So if we're looking at log, let's say we're looking at this log base 10 of 10, 10 is really 10 squared. So what's your exponent? Your exponent is 2. Let's look at some examples. Okay, so if we're going to convert from exponential to logarithmic, we have a log, our base is 3, our value is 243, and our exponent is 5. For number 2, we have the log, our base is 25, our value is 5, and we're equal to our exponent, which is 1/2. Go ahead and pause the video and do problems 4 and 5. For number 4, we have log, the base is 6, the value is 1/6, and our exponent is -1. And for 5, we have the log, our base is a, our value is c, and our exponent is b. For homework tonight, go ahead and do number 3 and number 6 and bring those into class. Let's take a look at number 7. So if we have a log, base 9 of 9 equals 1, we're going to convert that into exponents. So our base is 9, our exponent is 1, and our value is 9. So base, exponent, 9. We're going to round in a circle. So in the next example, our base is 2, our exponent is x, and our value is 512. So we have 2 to the x equals 512. Go ahead, pause the video, try number 10 and number 11. For number 10, we know that the base is 4, the exponent is -2, and our value is 1/16. So we have 4 to the -2 equals 1/16. In number 11, we have the base is b, to the 0 is 1. So we have base b to the 0 equals 1. For homework tonight, you're going to do number 9 and number 12 and bring those into class. Let's take a look at using mental math. I know that's your favorite. So let's go ahead and look at number 13. So if we have a log base 5 of 125, if base is 5, we know that 5 cubed is 125, so our answer is 3 for the exponent. Go ahead and pause the video and do number 14. And number 14 is 0.00001. There is a decimal, but the log is base 10. So number 10, we actually have log base 10, and we have 1 over, there's 1, 2, 3, 4, 5, so we have 10,000, and 10,000 is really 1 over 10 to the 5th, and that is really 10 to the negative 5th. So we have log base 10 of 10 to the negative 5th. Our exponent is negative 5 because that's what logs equal. For tonight, you're going to go ahead and do number 15 and bring it into class.